We're looking at section 5.2 now, and we're going to be doing integration. Okay, so we have to be able to switch gears. We were doing derivatives of natural log. Now we're doing the integrals that go along with those. So if you think about it, if we know that the derivative of ln of x is 1 over x, that's our derivative, right? We all know that by now. Then you should know that the integral of 1 over x is going to be the natural log of x, right? That should make total sense. If the derivative of natural log of x is 1 over x, then the integral of 1 over x is going to be natural log of x. Now, if you notice in this formula, though, it says x has to have an absolute value symbol around it. Here's the reason why. This has a base of e. So this means e to some power must equal x. Well, let's say that power is negative 10. Is e to the negative 10 going to be negative? No, that's 1 over e to the 10th. So this value of x can never be negative. It's impossible it could ever be negative. And so that's why the reason this formula has to have an absolute value here. So that's the only thing slightly confusing about the formula, is that we need absolute value. Now let me show you something else. If I had the integral of 1 over x squared, bless you, this would be the integral of x to the negative 2 dx, right? Everybody look. If I have the integral of 1 over x squared dx, I would write it as the integral of x to the negative 2 dx. I would now add 1, and I would divide by that. So that answer would be negative 1 over x. But that's if my exponent is a 2, if it's squared. Sometimes people want to use that same concept here. How would I rewrite 1 over x? X to the what power? Negative 1, right? That's another name for 1 over x, x to the negative 1. If I add 1 to this to integrate, what do you get? 0. That's the reason this has a special formula. Okay? Do you see what I'm saying? If I have 1 over x squared, I do this rewrite and I integrate, and I get this answer. But if I have 1 over x, I can't use that method. It has this special formula right here. Anytime the denominator is not just an x, then I have to do a u substitution. I'm going to let u equal whatever that denominator is. Let's do some examples. So on this one, I have a constant. I'm going to bring it out in front. Now it's just a matter of using substitution. So I've got negative 2, look up above, and what is that integral equal to? Natural log of x, absolute value, plus c. And that would be our answer. Okay? For the next one, I look at my denominator. It's something other than an x. So what did I just say you're going to let that equal? U. So I'm going to say u equals 4x minus 1. What is the derivative of that? 4 dx. If I had a 4 dx, that'd be perfect. But I have a 1 dx. I need to get a 1 dx. How do we get a 1 dx? Multiply by 1/4. So now I have that 1 dx. That 1 dx is going to get replaced with a 1/4 du. Now what we're left with on top is just a 1. And what is 4x minus 1? U. And so what is the integral of 1 over u? Integral of 1 over u is natural log, okay? So now I'm going to have 1/4 times the natural log of the absolute value of 4x minus 1 plus c. If you looked in the back of the book or on the solutions on Canvas, it might have it written like this. Would you understand why that means the same thing? Because this is to the 1/4 power, which means the 4th root. Okay? I even could have written this one as the natural log of 1 over x squared. Why am I no longer using absolute value here? Squared is going to be positive anyway. I don't need to make that restriction. Okay? So you might see it written like this, or you might see it as the natural log of x to the -2, which means 1 over x squared. All right, coming down here now. So we have more than just an x down here, so what are we going to have to do? U sub, u is x squared plus 1. What's that derivative going to be? 2x dx. But I only have an x dx. Here's my u, but I only have an x dx. So what am I going to have to multiply both sides by? 1/2. So now my 2's would cancel and I have the x dx that I need. So that x dx that's in a circle is going to get replaced with a 1/2 du. So now I'm just left with 1, and then this x squared plus 1 is a u. And by now you should know the integral of 1 over u, 1 over x, is going to be 1/2 the natural log of the absolute value of x squared plus 1 plus c. What if you didn't put an absolute value on that? Would it be okay?
Yes.
Why yes? It's getting squared, right? The x value, so wouldn't we end up with a positive no matter what? So if you use parentheses here, I'd still have to say okay. You know, no problem, because it's going to be positive anyway. You also could write it like this. Right? By condensing it, taking that and making it to the 1/2 power would be a square root. All right, I want you guys to think about number 4 on your own. It's a u substitution. See what you can do. Don't look up here until the end. All right, you should be about finished. Check your answer. Did you get it right? Great. All right, now we don't want to be those people that we learn a trick and we just think that's the only trick we're going to use. We've learned how to do this u substitution, and so we're like, okay, I'm going to use a u substitution every single time. No, we can't. Look at this problem. You look at it and you say, well, what if I let u equal x plus 1? Well, that derivative is just dx, and I'm still going to have that whole numerator. What if I let u equal x squared plus 3x plus 1? That derivative is 2x plus 3. That doesn't help either, because it doesn't match. When we run across a problem like this, we want to just divide these two. We literally want to divide them. What are some methods you know to divide polynomials? Synthetic or even long division, both of them. If I'm going to use synthetic, what is it that makes this equal 0? -1. So I would put a -1 in the box. I use my coefficients, 1, 3, 1. I bring this down. -1 times 1. I add. I multiply. And I add. So what that tells me then is this is going to be the remainder. So another name for this whole thing would be x plus 2 minus 1 over what we were dividing by, because that was my remainder. See, this is going to be to the first power. This is my constant. This is my remainder. So it goes over top of what I was dividing by. Now, this actually turns into 3 problems. See, I have to integrate this one. That's one of my problems. Here's my next problem to integrate. And here's my last one to integrate. See, I have to integrate this term, and this term. It's not that bad, though. What's this integral? If I just gave you that problem by itself, what's the answer? Add 1 and divide. What is it? X squared over 2. Everyone's a little unsure, afraid to say it loudly. What's the integral of 2? 2x. There we go. Now, when I integrate this, I can't really integrate it because I have this down here. So just for this part, I'm going to have to do a little u substitution. I'm going to have to say u equals x plus 1, du equals dx. I've already integrated these, though, so they don't have integral symbols because I already did them. But this one I did not do yet. So this one turns into minus the integral of, and then here's du. I'm going to have 1 over u du. Once again, this has been integrated, this has been integrated. This one, to integrate, I had to do a u sub. So here's my answer. X squared over 2 plus 2x minus the integral of 1 over u is natural log of the u, absolute value, plus c. All right? That's it. Okay, now let's say you didn't know how to do synthetic division on this. What if you had to do long division? Let me just remind you of long division. If I had to do long division, I would write it exactly how it is. This divided by that. What's x squared divided by x? What's x times x? X squared plus 1x. Now I have to subtract, and I get 2x. I have to bring this down. What's 2x divided by x? 2x divided by x is 2. Now I have to multiply. 2 times x is 2x. 2 times 1 is 2. Now I have to subtract. So that's 0. This is -1. Do you see how my answer is x plus 2 with a remainder of -1? Just like it was here, x plus 2 with a remainder of -1. Yes? You can do it either way. But we will still get the same answer. All right. Let's stop there. I want you to practice some problems on page 330.